looking at Leetcode 509 Fibonacci number, and we're just going to solve this in the context of looking at recursion as a tree. We're not going to look at the most efficient way to solve this. We're just going to look at the recursive way. And the idea behind that is I just want to give a little bit of a primer or a warm-up into the next problem sets that we're going to be doing, which is dealing with combinations, permutations, and subsets. So just want to do a quick refresher on recursion and also how to look at recursion as a tree. So here we have Fibonacci numbers denoted by f of n form a sequence called Fibonacci Sequence, and it's such that each number is the sum of the two preceding ones starting from 0 and 1, that is. So here fib of 0 is 0, fib of 1 is 1, okay, where f of n is equal to f of n minus 1 plus f of n minus 2 for n is greater than 1. So here fib of 2 is going to be 1, fib of 3 is 2, and fib of 4 is 3. Okay, so let's say we have fib of 4. Okay, so n is going to equal 4. Well, let's calculate what our answer is going to be. So fib of 1 is 1, then it's going to be 1. Then we're going to take the next two, and that's going to be 2. We're going to take this one and that one, so we're going to take the previous two numbers and add them. That's going to be 3, and then we'll get our fourth number, which is 3. Okay, and so we're just going to use recursion here, and the way we want to do it is if our main function is fib of 4, then there's two choices we can make on this. Okay, we can create a recursive tree. There's two choices. We can either subtract 1 or we can subtract 2. Right? So here we're going to get fib of 3, and here we get fib of 2. All right, so moving forward, we're gonna get to 3, and we have two choices. We can subtract 1 or we can subtract 2. So here we'll get fib of 2, and let's see here, and fib of 1. And now our base case is going to be if the input, if n equals 1, we return 1, and if n equals 0, we return 0. So here when we subtract 2 from 3, we're going to get 1, and so we're going to return 1 all the way up the chain. Okay? And then here on our left side, we're going to subtract 1 and subtract 2. So here, this is going to return 1, and then this is going to return 0 up the chain. Okay? Similarly here, we're going to subtract 1 and subtract 2. This is going to return 0, and this is going to return 1. And so you can see at the base case, it's going to return 1, 1, and 1, and that's going to add up as it goes all the way up the call stack. And then we finally return that. Okay, so I just wanted to quickly do this just to give you a refresher on how to view recursion as a tree. All right, so we're just going to have our two base cases here. So if n equals 0, we return 0. If n equals 1, we return 1. And then all we do is we just return fib of n minus 1 plus fib of n minus 2. Okay, we can run that, and we're good. Now, this is not the most efficient way. It's actually a very inefficient way. You can look into tabulation, memoization, or even a dynamic or a greedy approach that's much, much more efficient. But I'll leave that for a different video. I just wanted to take a second to review recursion. That way we have a good little primer on the next couple questions we're going to do. Okay, so that is Leetcode 509 Fibonacci number. Hope you guys enjoyed it, and I'll see you all on the next one.